be in a boat following them, within 30 meters to keep up with where they are for who knows how many years. We need tags that are about 0.2 grams. That's tiny. And the technology just is not there yet for little tiny baby hatchlings. And it really wasn't until a few years ago, about 10 years ago or so, right when I finished up my dissertation, that some bird tags, and I did get inspiration from the bird world, that some bird tags that were solar powered were developed. And those tags, because they were solar powered, they could recharge without having huge, heavy batteries. So they were able to reduce the size and the weight of the tags to about 9 grams. That's about the size of part of my thumb, maybe. That's a quarter next to the tag there. And it's still too heavy for a hatchling, but we can put them on turtles that are about 10 centimeters, about the size of a cereal bowl. And I worked with Jeanette Weineken down at FAU, Florida Atlantic University, and she had turtles in tanks. We were able to test out different attachment methods for these tags to see what would work really well on fast-growing baby turtles. And we had some problems. We found very quickly that epoxies that work really well in older turtles fall off within a week or two on baby turtles. And that's because the turtles are growing so fast. Their shell is shedding very quickly. It peels. And we tried, we put bathing suits on these guys. We were thinking that we could engineer like a wardrobe failure where eventually yeah, exactly, Janet Jackson and everything, that they would break out and be able to swim free of any harness that we created. Nothing worked. We tried hard epoxies that worked for about 3 to 4 years on larger turtles. They fell off within a week or two on the babies. And what we realized, and if you look at this last picture here, you see a whole bunch of kind of white material. That's the peeling shell that came off with the tag as they were cleanly shed for the backs of the turtles. And the shells of the turtles are the same thing as our fingernails and our toenails. And we were in the lab one day and we were scratching our head thinking, we have these tags and we have a bunch of money that somebody's trusted us with to try to figure out a way to tag and track these guys. Nothing is working. What are we going to do? And we had this aha moment where Jeanette had always had these really great pedicures that she would get. And we, was admiring her pedicure, and we kind of look at each other and realize that turtle shells are the same thing as, fingernails. So what would you do for peeling toenails or fingernails? We called Marisol. Marisol is a manicurist at Just Nails down in Boca Raton, Florida. She is awesome. She was the inspiration for solving the sea turtle lost years. Jeanette called her, asked her what she would do for peeling nails. Marisol recommended that we use an acrylic nail fill kit or an acrylic base coat. So we went out to CVS, bought a Kiss nail fill, an acrylic nail fill kit, and painted it on the back of the turtle shells. And then tried a bunch of different attachment methods, and the one that worked best was a flexible tag attachment that allowed the turtles to grow. We ended up using a couple strips of old wetsuit on either side of this ridge that goes down the center of the turtle shell. We used toupee glue for that. And then we used some aquarium silicone, which is flexible, and everything was pretty much low toxicity, non-toxic because humans put it on themselves. And then we stuck the tag on there. And those tags stayed on in the lab for over 90 days, and I've had tracks of over 300 days using this attachment method. And we created kind of a nice little teardrop shape to create more hydrodynamic friendly surface. And what was especially nice is that these little turtles mostly remain at the sea surface. So those solar tags were able to recharge, and we were able to get some really great information. We did find that the green turtle species that we worked with did not really work too well. If somebody can reverse engineer what those what those shells are made of, I think that they would probably become bazillionaires in the boat anti-foulant industry. There's something about those guys, but we did find another 3M adhesive, 3M 5200, if you know boat hulls and boat adhesives. That worked fairly well. We do cover them up a little bit so they're not terribly looking very much like a big white blob on the backs of the turtle shells, but that gives you an idea of what we did. So that resulted in the very first satellite tracks of baby turtles in the Atlantic. And we were able to also tag and track green turtles. We did confirm that they were offshore animals. All those little black lines indicate the turtles' movements. And we did confirm that they were oceanic, meaning that they remained off the continental shelf. They also remain at the sea surface because those tags were charging really well. And so we were getting great hits off of them. The turtles likely were not diving very much at all. And so we could confirm that they were oceanic surface dwellers. Whether they stayed in that big circle current, yes and no. Some did, but some went into the Sargasso Sea, which was unusual and unexpected, and it was pretty cool to see. This is one example of a turtle that kind of took a turn off of Cape Hatteras and then went towards Bermuda, which is that little tiny black dot out in the eastern Sargasso Sea before the tag ceased transmitting. So this is very different behavior than what was expected. And what about sargassum? I would argue that you have that big current, that big gyre system, and it's probably kind of like a playpen. They don't want to leave the gyre, but they can go into the middle of the gyre, and that's okay. And sargassum, we haven't managed to really get a feel for where it is and what its behavior is yet. But we know that the turtles definitely associate with it, and they hang out on top. And what you can see in that red circle there, that's a little turtle that's hiding. So if you're a hungry predator, it gives you protection. What we also found is those tags had little temperature sensors. And those temperature sensors were reading above like 4 to 6 degrees Celsius warmer than any ocean buoy data that we could find, any predicted model data that we could see, any of the ocean circulation models, everything we were looking at, the tags and the turtles were hotter than what we would expect. And if you're a little tiny turtle that is cold-blooded, and if you're warm, that means that your metabolism is kicked up, your immune system is working, you're probably eating faster and more, and you're going to grow faster. So evolutionarily, that kind of makes sense. If they're remaining at the sea surface, they're basking in the sunlight, they're warmer because they have dark little brown shells, and the sun's heating them up. And so there's so many cool things that we are now starting to think about with these little guys. A lot of it has to do with their physiology. And sargassum is, again, this brown macroalgae. It kind of originates in the North Atlantic in the Gulf of Mexico. It rides currents up the coast of the US into the North Atlantic, and then it settles down into the Sargasso Sea, which is named after it. And that's where we were finding, the turtles were following a very similar pattern in their movements. And that makes sense because these little guys are likely finding food and warmth and protection, so it makes sense. Why leave? The data from some of my early tracks were used by the U.S. Fish and the National Marine Fisheries Service, and they established critical habitat under the Endangered Species Act for sargassum based on those early tracks, and that is indicated in the green of that second map. That is offshore nursery habitat for loggerheads established as critical habitat under the Endangered Species Act and it was added to the Federal Register in 2014, so that's pretty exciting. There was a piece, though, that was missing, and we know that sargassum occurs there, and it's in the Gulf of Mexico, about in the same place where the Deepwater Horizon oil spill happened. And I happened to be in the right place at the right time before I came to UCF, where I was working for the National Marine Fisheries Service down in Miami. I ended up getting some money to be able to go offshore and catch up to 4 different species. After we figured out how to tag and track these guys, then the oil spill happened. I was in the right place at the right time. And we were able to get the first wild-caught turtles satellite tracked from the Gulf of Mexico. We would go offshore about 100 plus miles offshore in small boats. We would look for the sargassum lines, dip net the turtles off the back, catch whatever we could catch, 4 different species, and then basically take whatever sample we could, measure them, take blood, look at the stable isotope analyses, what they were eating, foraging ecology, where they're coming from, stock of origin, and then put a satellite tag on them and release them. One of the key things that we found was that almost every turtle that we had a fecal sample from had plastics. So those little guys were eating a lot of plastic offshore. But where did they go? And this is what was also very exciting. We had some that left the Gulf of Mexico. We had 2 different species that we were able to track a number of turtles for. One species would significantly orient just as a species. They would stay within the Gulf of Mexico, up in the Panhandle. They would head towards the Big Bend area. Other species would leave, or they would orient to possibly leave the Gulf of Mexico. We had turtles that we tracked that went from offshore waters to inshore waters and then back offshore again. So that raises questions about whether this shift from offshore to inshore is really a one-way shift. And we're seeing a lot of plasticity in that behavior where it's not so clear-cut. These ontogenetic shifts are pretty much two-way, perhaps. We released oceanographic drifters with the turtles, and those were passive drifting buckets with GPS tags. Those little baby turtles behaved incredibly differently from a known passive drifter. So we were able to demonstrate, and that second image there, the blue curlicues, that's where a couple drifters went, and you can see a very directed movement in the green turtle, green line there for a green turtle. And so we were able to document and show that these little turtles are not 100% passive drifting as they had always just been assumed. So that was really exciting. And I also, about the time I was hired, my drifters washed up in Texas with a whole bunch of cocaine and square groupers, marijuana bales, and the Coast Guard was asking some pretty tough questions. Thankfully, I was still working for a federal agency, and they believed me that I was not tracking drugs, and I was able to give them the bucket information, the drifter information, and they could back calculate where the drugs may have been dropped. So the sea turtle lost years, it's a lot more complex, and we're showing that they're active little swimmers, they're behaving very differently than what we expect, and some of what our protections that are in place may not be 100% accurate, or they may not fully cover where these little guys need to be protected. We still have massive data gaps all over the world. We do have a lot of information from the North Atlantic. However, we're still missing global information. So there's a lot of work that needs to be done. And part of the work that we do at UCF, we have a lot of global collaborations. I'm doing some work down in Brazil with in the South Atlantic, and the turtles down there are completely blowing our minds, doing something completely different. And we're working with the Sargasso Sea Commission. They're establishing, hopefully, a World Heritage Site in the Sargasso Sea, and our data will help go towards the establishment of that. But what does this mean? It means that there's a lot that we don't know. And if you think back to that patchwork quilt, we have all these different patches that kind of look alike in that quilt that I showed you, but the reality is we might need different patches for different parts of the world. We may need a lot of different ideas. Those quilts may not be square or rectangular, they may be really wonky looking. We have to start thinking a little bit differently and kind of break out of our human biases and our, how we limit ourselves as scientists, because it limits our science, in my argument. Next steps, we're going to be tagging and tracking baby turtles with smaller tags that are deployed using the International Space Station and a lower orbiting receiver. And we're hoping to test and tag a whole bunch of new baby turtles that are much smaller than the ones that we've managed to tag so far. And we're continuing to do a whole life history approach, looking at stock of origin, genetics, and disease ecology across all the life stages. if you're interested, we do have some Facebook pages. We have Twitter and Instagram. You can see lots of pictures from all our projects. And thank you very much for coming. And I see that that middle picture in there is somebody very familiar in the audience. So thank you guys very much.